G'day folks, welcome to an EcoFarmers Discovery, the Audiobook companion podcast. Join Ewan Campbell as he takes a deep dive into his book, uncovering all the secrets of soil health, biology, and true farm independence. You can listen along to his book on Spotify or download from Audible, and then catch us here as we deep dive into the events of each chapter. We're now up to chapter 14. Let's go. Okay, Ewan, welcome back to chapter 14. So, Dr Maynard Murray's research. Interesting guy. What was it about his work that most captured your attention?
The results. I mean, what he was saying about the health in the ocean and what was happening in fresh water, and I'm going, I've seen this stuff, I've been fishing enough and seen big, fat, healthy, snapper come up, and there was a lot of stuff went through my head about in my earlier days when I'd been over in Wales, about the sea run trout and the salmon that came up the river. They relied on fresh water to do their reproduction, but obviously they weren't reproducing because the salmon weren't there to come back. So there was a whole lot of stuff going on, and I was saying, yeah, he's right. So if he's right, there's obviously a mineralogy in the sea that, I just thought it was straight minerals at the time, but it's really interesting when you actually break down seawater, is that man cannot produce seawater.
That's weird.
Yeah,
you can't just get the composition of it.
No,
right?
man has not been able to produce seawater, and
that's mind blowing when you really think about it.
Yeah, they cannot do it. So it needs a biological function to actually create seawater.
Right, which tells you that we're trying to make something that isn't alive.
Yes, that's right. So it's alive. Seawater is alive.
Yeah.
And so, Murray talked about this process of how everything was so healthy in that. And after being to the States and working with Brookside and seeing probably some of the lands, some of the amazing mineralised soils that they have from glacial moraines, and that's certainly out of an inland sea and right through the Midwest, when they applied some of these products back into it and they had an amazing result, I'm not surprised because the minerals would have been there, but he was reintroducing a biology, and which it took quite some time for me to fully understand. And I daren't say fully understand. God, it's just such a long-winded subject. But this is where the cyanobacteria, otherwise known as blue-green algae or whatever, the healthy ones that come out of the ocean, they're the greatest photosynthesizer on the planet. They're the biggest carbon accumulator. They're everything. And they live in everywhere, but they can't handle chemicals. They can't handle chemicals at all. They'll handle minus 40 degrees and they'll handle plus 70. And as soon as the condition's right, they'll reproduce at a hell of a rate of knots, but they cannot handle chemicals.
Wow. Can you explain the significance of the comparison between ocean mammals and land animals in his research?
Well, this is the thing. Is like they were exposed to living in seawater, which is fully comprehended blood in a sense. It's like seawater is the same as our bodies, and the blood in our bodies, and here they are, the fish are swimming around in this fully mineralised, healthy, and then they come to freshwater and it's not. Now, there's healthier freshwater places than other freshwater places. I mean, water has a huge amount of different qualities about it. So you could see, well, okay, if it's mineralised that way, nature's built it that way. And then if you start looking at where were the healthiest places certainly in this country to start with, they were always on the marine flats. So there was always an influence of the ocean at some stage into what was growing in the biology and into what grew from that. So there was always a connection to the ocean, to this health. It didn't happen, just by accident. And then even to the point of watching animals on, around Taihape, Raetihi, Wanganui, it's all papa country. It's all come up from underneath the ocean. It's incredibly healthy country originally. And, even though it was rough as guts, they used to cut all the timber down and they grew some hellish and good sheep and cattle in there.
Wow.
And, right down the east coast of the North Island, specifically out around Gisborne and that, it's all pushed up seafloor, which, over a time frame, it'd be great to actually put a picture where you could actually see it happen.
Yeah. Were you going to say I thought you were going to say over time frame, how long does it take to deplete it of those minerals for the land animals?
Well, I think it's your biggest thing is you've depleted the mechanism and the health of it by what we're adding into it. And then,
as opposed to stripping it of things, you're depleting it of its ability to give you those things.
That's right.
Right.
Yeah, no, they haven't really gone anywhere. I mean, that's what the total soil test does all the time, is that we keep showing up and going, well, they're still there.
Right.
And you've just changed the form that the biology can get at, or you've brought aluminium out to play. That's the other big no-no of cyanobacteria is aluminium. And I mean, the population goes and buys this shit at the supermarket as underarm, antiperspirant. Why is the active ingredient in these antiperspirants? Oh, it's aluminium sulfate, because aluminium kills bacteria. And so as soon as you go into your soils and you lift the aluminium content, well, it kills the cyanobacteria. And so as soon as you put a chemical on it, it's a plant, it's an organism, it's like boom, gone. And then, products like Roundup, they're not only kill weeds and everything like that, but they're antibiotic. It's an antibiotic.
Yeah, that's a strange concept to hear that for the first time, that it's an antibiotic.
Yeah, so it just kills the shit off. And then that is what is needed to actually start this life cycle in the process. So, yeah.
So what motivated you to try using seawater as a fertilizer?
I could get it for nothing.
Yeah.
I'd be down the beach. It was nothing to go down the beach and grab some seawater. And I'm reading Maynard Murray. I said, this is pretty exciting shit. And for nothing? Yeah.
So how did the initial trials go?
Oh, they were great. And actually, when I look back on them, then I had to actually really take two step, because the original marine clay that I got for making the electrical activity, and I got from Aotearoa, it obviously had seawater and cyanobacteria, and I actually was seeing the same results and going, okay. It took a while for me I was a bit thick, I think. But yeah, like the results were quite phenomenal. You could see the squares, and I just used a paddock out from the house, and I was just looking out the window and going, oh, shit, I can see that. And, as I spoke about in the book, I went for a wander one day and just sprayed all over the place. And I forgot all about it. And then one day I walked around the paddock and I just followed where I'd walked all over the place. It was just so obvious to see where all this, where it had gone.
Where the trail had been.
And you go, well, that's bloody amazing. That's really cool. Let's do this some more,
Yeah.
But, I was noticing the worm castings in these.
I was going to ask you about the worm casting. Can you explain what a worm casting is?
Oh, well, the worms go down and eat whatever they eat. I mean, they don't eat dirt. They eat biology, like fungal, nematodes. So they eat all that shit, and then they shit.
Right.
And that's a worm cast.
It's their leave-behinds.
It's their excrement.
Their excrement.
Right? Yeah. Okay. So in their gut, it's all getting ground up, and it's all biology, and it's all been laid down. So now we have a nutrient pile, and you just think about it. I mean, people explain worms to me as the whales of the soil. Like, they're the big guys.
Okay.
Because they go down there and they eat everybody up, and they're the last in the life cycle sort of thing.
Right.
And I get to understand that process. But what I have come to grips with is they love cyanobacteria. They love it. It's like going to the Chinese smorgasbord. Let's have it.
Wow.
And so the biggest indication is when you get cyanobacteria functioning properly, you'll have worm castings. I mean, you'll have worm castings like you've never seen before. Like specifically from about April on, more May, June, when it's moist enough and all the biological functions working properly. I've had up to 15 to 20 millimeters of worm castings across the whole paddock. I mean, thick, like that, across the whole paddock. It's just worm castings. And you put the stock in the paddock and you think, oh my God, look at the mess we've made. And it's just them trampling down all the worm castings. A couple of days later in a shower of rain, and all of a sudden everything's green. And it's like, oh, shit, what happened? And in the springtime, what happened from that was all these little fine feeder roots come up on the surface to get the nutrient out of the worm castings.
Oh, okay. Okay, that makes sense. So what were the biggest logistical challenges in collecting and applying seawater on the farm?
Oh, just fun, really. look, I went down there with a 20-litre container, and then I got this brainwave. Let's get a helicopter in and spray it over the whole place. Okay.
That could be a logistical challenge.
Well, it wasn't. But
What's your attempt to solve a logistical challenge?
yeah. Well, we got. God, I can't remember the name of the guy that had the milk tanker. Anyway, we went down to the beach, and I had a little 8-foot-long aluminium boat, and I got a 75 mil petrol-powered pump to pump the. And, it said in the book, it was hilarious, really. I got out there. We went out there about 15 metres, and I just wanted to get into clear water and start pumping it in. And, I hadn't latched the bloody pipe in properly. And I pulled start, and it burst into life brilliantly, and it just, water went everywhere. This pipe blew off, and there was water, and it was going in the boat. And I just looked up, and there was these two guys sitting on the bonnet of a car watching this whole process. And they fell off laughing so much. And I just said,
funny.
Thanks for the entertainment, guys. Yeah. So immediately sorted that out. But it was a little bit of fun. Thankfully, the milk tanker guy was great, and we went and got a truck and trailer the first thing in the morning, and we got another truck in the afternoon, which was enough to do the whole farm at 100 litres a hectare. The logistical thing about seawater is the bulk, because you're looking only at a very small portion of it that's actually got all the process. I mean, it's 3.5% total solids, seawater. Of that, 90-something% of it's sodium chloride. Then there's the other minerals and the biology that go with it. So can't we get that concentrated? And as we go further in the book, it's like we found ways to get a concentrated product that could be mixed in and utilised easily.
Yeah, okay. So I was going to sort of ask you, should someone listening to this go down and get a boat and pump seawater onto their property?
Well, I've seen plenty that do it, and they've added into their brews and all sorts of things.
So you're not saying, oh, no, don't do it, I've got something better. You said do it if you want. Is there any harm doing it?
No.
Okay, but you have now mentioned 2 different depths of extraction in the chapter. What was it, 40 metres or something?
Oh, that was René.
No, that was his research, right?
Yeah, René Quinton, who was the French scientist, and he was going way out to sea and going to 20 to 40 metres to try and get the cleanest possible seawater he could get for doing his experiments and putting it in human blood.
Dog blood?
Well, he actually was a physician for the kings at the time too, and he was using it in dogs and whatever. And
he tried on humans?
Yeah.
What year was this?
Late 1800s.
Yeah, they had different ethics committees then, I think.
None. Oh, yeah, that's right. It's like, well, the king must have thought it was pretty good, but
you do what you want. Yeah.
Yeah. Well, look at it.
Incredible advances from what they tried.
Well, look at it. If you go to Grasmere Saltworks, the salt they harvest for that end up getting purified and utilised in saline solution in the hospitals.
And what's the first thing they give you in hospital when you arrive for anything at all?
Yeah.
A bag of saline in your arm.
Yeah, okay. Yeah. So, salt's really bad for us. We shouldn't take salt, but first thing you do when you get to hospital is you get a saline.
Get a bag of it. Yeah, true.
And I reckon they'd be far better off to go and get the right composition of seawater and put that straight in.
Yeah, that's really interesting. Because it would be alive, and we can't reproduce it.
That's right.
Yeah.
And it allows for all those little intricacies of the seawater to be immediately available in our body.
Yeah. Interesting. I've just realised I don't have a single question about the dog's blood being replaced by seawater. So you've got to listen to that chapter if you've skipped ahead. Gone to that.
It was incredible what he did. Yeah. And this is the thing is that
the dogs were healthier.
Yeah, they were bounding around all over the place, and so this is stuff that we keep seeing time and time again. Going, okay, that worked in the ocean. Okay, so what's the difference? How does this work? Because basically, our soils, even though it may not look like it, they function very like an ocean.
Yeah, that's interesting. Okay, so how does seawater compare to traditional fertilizers like lime or serpentine?
They're completely different beasts. The seawater thing brings a biology, right, and that's brought the cyanobacteria, and they also. You've got to really crack down on this process when you realise is that seawater is the same chemical composition as our blood, and that we can't reproduce seawater. That can only be done by microbes. And this cyanobacteria process they're the original microbe on the planet, and they grew up in the ocean. So if we came or arose from this process, we probably should look at the original starting point.
Yeah, first principles thinking.
Yeah, first principle. And the crazy thing about it is the research has shown that cyanobacteria can re-strand its DNA back to perfection whenever it's gone into an aberrant process. So like if they've given the right environment, whatever you do, it goes back to the original blueprint. Now, that is where we need to be. I mean, what's locked in our DNA and the information that's inside of it, oh my God, you can't even imagine that. You know, like they've written whole books and they're only scratching the surface, like the I Ching and that. Like that's the 64 segments of the DNA. Well, there's the I Ching. That's our spinal column. These are things oh God, it's mind-boggling to see how much information's there and how much can be expanded on. Let alone going, oh, well, I'm going to change this gene. And you got no idea how they were supposed to work to start with. None whatsoever. And nor have you perfected how they work to start with to see if you can make them better. All what's happened is that we've killed them off. And then gone, oh, everything's wrong. And going, well, we need to get that stuff back in the nutrition, because what has been shown is that when the starting point follows through, so if you have the perfect DNA in the cyanobacteria and it comes through in the plant and it comes through in the animal, it all follows on. That is the quickest and easiest and safest and healthiest way to remedy our health genetic issues. This getting in the way of chopping and changing shit when you don't understand what the information that's in there, how it's supposed to function, the perfection of the minerals inside of that DNA, you know, by just changing to a different isotope of a mineral, it will change the DNA.
Yeah, well, resetting our DNA is a hot topic at the moment.
Yeah. Well, I know a place that does it every day. It's just over there at the beach. And that's the way we look at our farm, and that's where we get massive carbon growth, when we actually give it the soil, the ingredients, so that the cyanobacteria can go to work. And then the carbon grows, which means we're actually in the right place.
Right. So were there any surprising interactions between the seawater and...
yeah. Well, that was the big hitter, was when we put the serpentine on.
Yeah.
There was a few paddocks that we couldn't get to at that stage with the helicopter, with the spreaders, while we were putting the seawater on. And so where the cows were or animals, and we couldn't get it on, and we put it on afterwards, didn't fire at all. It just pretty okay. And it took me a long time to unwind it. And I thought the serpentine was just the magnesium I was after. But what we inadvertently did was give the cyanobacteria magnesium and silicon to actually build the structure which the microbe needs to grow. And we had an explosion. I mean, the farm just exploded. I remember Mike Rawson. I can still remember him. I'm opening a gate to him, and he goes, "When did you regrass the farm, Ewan?" I said, "I didn't." And he was just like, "What?" And it did look like I'd regrassed the farm, because there was so much germination, and it was just beautiful over the whole place. Wow. And that was an interreaction. We had the electrical side working. We brought some more silicon in with the serpentine. We dropped the cyanobacteria on top right at the time, and boof, it just went bonkers.
Wow.
And it was fantastic.
Can this be the chapter where you discuss whatever happened to serpentine briefly? Because I know you mentioned it in the prior chapter, and what time frame are we talking about at this point in your life in the chapter? Because when you were using it before it was taken off the market was about what year?
Mid-2000s. I started really getting into it.
All right. So anyone interested in the history of the events that took place there, why was it removed? What was it based on?
I think a cost effectiveness of Mike pulling it out of the ground, because they were having trouble filing the seams. I don't know how many tons they dragged out of the ground from
right.
area.
So for the person who doesn't understand, this is pulled out of rocks?
Yeah, it is. It's a mining operation. I mean, there was a hell of a hole in the ground what they used to dig it out from.
Okay.
And I don't think that it financially viable. And then this whole thing came about that I think there was a big issue about asbestos as well.
I was going to just ask you about that. So is it viewed as looking a lot like asbestos,
yes,
but it wasn't?
Is. Yes.
Okay.
That's right. And like you could tell from the people that worked at the quarry, they all didn't get asbestos poisoning or anything like that.
So it wasn't asbestos?
No, it wasn't asbestos. But, like you come along in a chemistry perspective and say, well, that's asbestos, and going, well, no, you got to look at the layering structure and all the other. And that's something I don't fully understand, but I did take a lot of notice at the time and certainly didn't see any of those effects of asbestos poisoning on any of the workers or anything else.
Okay, so serpentine is in the category of fertiliser.
Well, it was in this country. They used to put it in with superphosphate and make serpentine super as a
super.
Yeah,
okay.
as a magnesium supplement, and
it was good.
Anything
better if you did these other things with it.
Well, yeah. Put it this way: I'd never seen a reaction with serpentine like what we got out of the electricity and the other bits and pieces, and I don't think Mike Rorison had either.
Okay,
and he just like, what have you done?
So, am I right in thinking that when they can find an area to mine that could be useful on a farm, then it only has a limited life until the mine's depleted, then it's like a fashion. It's like it comes for a few decades and it's gone because they can't repeat something once they've used it up.
That's right. Yeah, and I had this long discussion last night about these issues of people having choices. Like in this world, we have choices for some things, and then some of those choices should never have been given, like the likes of DDT should never ever have made it into the mainstream agriculture. But it was a choice to put DDT on to kill your grass grub, or it was a choice for fertilizer companies to put it in there, or it was a choice there. And then one day, the books like Silent Spring that really showed the DDT issue, especially in the bald eagles in the US, and all of a sudden it's gone. End of story.
Because they realise how terrible it is.
Yeah.
Yeah.
That's it. It's gone. So farmers had to find something else to do. So
this is a problem, right? Because whether it's DDT or serpentine, if you're relying on something that's only going to be around for a while, you base your whole practice around it and it's gone, and you haven't learned how the rest of the biology works, you're really stuck, right? Because you've lost a huge tool and you don't know what other tools you can use.
That's right. I mean, the same thing with the basic slag. I mean, it was a brilliant product. Then, as I spoke about in previous chapter, then it caused all sorts of mayhem, and then it was pulled from the market. But all it did was give you an opportunity to see something. Well, that's the way I look at it. It gave me an opportunity to see something that I would never have seen before, and then try to come to grips with it. What was it that we saw? Well, how do we do this in nature, or how did nature do this before? Because invariably, nature always had the answers and always does.
Well, speaking of Maynard Murray and his information to use seawater as fungicide, how did that influence your perspective?
Just let's go try it. And, those vegetable growers that put some on and tried it, they said it was the fastest fungicide they'd ever had, and that was at 6-1. And, this is the sort of stuff that, facial eczema and all this sort of stuff. They're going on about these researchers and all this stuff and all these bloody zinc products and all these fungicides that you got to use. And it's like, just get a life, will you? If you've got a problem, you've got to spray it quickly. Go and get some seawater or put some lime on, or both.
Seems very simple. The vegetable growers you mentioned, they were potato and onion crops, right? What were the outcomes there?
It just nailed the fungus straight away. And
do they have to use a dilution of it, or
yeah.
or strengthen the?
No, they diluted it down to 6-1.
6-1.
6 parts of fresh water and 1 part of seawater. Yeah.
Okay. All right. Well, in terms of scaling and viability, with the costs and logistics involved, do you think seawater fertilisation is scalable for widespread use?
We found ways of actually shortcutting it. Basically, you want to get the cyanobacteria on the land. And, Grassmere does a great way of concentrating products at the salt works. I mean, as does all the salt works around the world. When they dehydrate seawater, they get byproducts that are absolutely loaded with cyanobacteria.
Sorry, Ewan, dumb question, but who or what is Grassmere?
Oh, okay. So Grassmere is the salt works in the northeastern side of the South Island, just south of Blenheim. Right. And they bring seawater in, and they dehydrate it to get it down to the salt Salt works.
Got it.
And their number one product is salt that they're getting off. But there are other products that go with it. There are cyanobacteria in those products, and then so you've got a super concentrated source at that point of mineralogy and the ability to hold the cyanobacteria. So you can use them. It doesn't matter if you dry them out because it doesn't kill them.
So this takes you back to what you were saying before about the methods to make it more accessible for farmers, right? So I interrupted you. Sorry.
Well, that's just a way of finding a concentrated product that's loaded with cyanobacteria and going, okay, well, it's a dry product that we've got now. We can put it in a brew and spread it on without having to have aeroplanes and liquid and all that sort of thing.
Sure.
What you're looking at is every time that you put liquid with something, you've got extra weight.
Heavy, really heavy.
Yes.
Yeah.
And weight, freight, and aeroplanes and trucks don't go together as far as cost effectiveness.
Sure. So you effectively want it to arrive as a powder.
Basically, yeah. And you don't have to put much on because it's a seriously concentrated product. I mean, we're using around 50 kilos of concentrated product per hectare from the start to actually re-inoculate with the cyanobacteria. So it's not much.
Okay, well, in terms of broader implications, how do you think processes like seawater fertilization will reshape sustainable farming?
Oh, look, if you don't have cyanobacteria in your soil, I haven't seen a real accumulation of carbon. I haven't seen the whole process function without it.
Okay.
I've seen lots of people doing grazing experiments and whatever on healthy soils, and have good results. I mean, Roots So Deep is a good example of that. I see people using marine-based products on land, and inadvertently they don't realise what's actually causing the result. But that's fine. I mean, it works. I mean, we just isolated that. Okay, these are the guys that do the donkey work, and there's nothing on the planet that can keep up with them. As far as you give them a clean environment, all the materials they need, and some electricity, as what happens when they get to the poles. You look at that is the most prolific cyanobacteria production come the springtime every year anywhere on the planet. Now, it's very interesting that is also where the most soluble silica is in all seawater. It runs around. There's nothing accidental here. So you have way more electromagnetic energy right next to the pole. You have these cyanobacteria in freezing conditions photosynthesizing and going nuts. And you have soluble silica. And where does all the sea life migrate to in the springtime? You see these bloody great whales. They're heading from one pole to another to get that abundance that comes in the springtime. So we have cyanobacteria, krill, herrings, everything else that goes with it.
Okay, so for people hearing this for the first time, some of it's going to seem quite unconventional, right?
It's nature.
It's nature, sure. But how can we get common sense into this and using that to adopt an unconventional approach?
Well, when you call it an unconventional approach, and going, well, let's just stop and take a bit of a look at how we got here to start with and what were the circumstances. And, it doesn't matter whether you're looking at the evolution process or that we dropped out of a spaceship or whatever. It doesn't matter if you look at the Bible being the absolute sacrosanct. If you actually look at the Bible and look under Job, my mother gave it to me first, and I said, "What do you want me to read Job for?" I'm going,
Job,
yeah. It didn't have an E on it; it was Job. And so, okay, Job. So I looked at it and I started laughing, and Mum said to me, "What are you laughing at?" And I said, "I've realised that the whole what they're talking about in Job was actually about he was reinvigorating the beeves or whatever. It was actually his own health they were talking about, and they talked about sea minerals and sea ointments, and there was processes there. They talked about Leo, and these are the Leo goes back to the star signs and the particular
the constellation of Leo.
Yeah, and they're talking about the different minerals that go with this, and they said that Job reinvigorated as this, that, and he lived to 140 years old.
The constellation of Leo is really historically important. I mean, the Sphinx is perfectly aligned with it in Egypt.
All 12 of them are incredibly important, and we'll get to that part with the salts further in the book. But like, it was just an indication if you can read this stuff, and I'd read a whole lot of other material on the salts, which we'll talk about further down the track. But hold on, this is a nutritional indictment of what we should be doing to bring our health back to ourselves. It wasn't about Joe being a farmer and all his beeves. It was about Joe being healthy and unto himself.
What is a beeve?
Well, like you had beef animals.
Oh, it's beef. Sorry,
yeah,
I'm mishearing you. Right, yeah, and all this beef,
Yeah. And so, like, Mum's Bible had come from Elstow, the old church there. It was, it was over 100 years old, I think. And so, it's a language that's hard to read, and but when you've read enough law stuff like I have, and you old stuff, you start to see the words and the pictures and he's talking about his nutrition and how healthy he became, and then he lived a lot longer, and so that's a completely different view of it than what anyone else I heard talk about it. So,
gee, you'd probably be very good with Shakespeare. Funnily enough, with that correlation. Yeah, because it's a different sort of way of expressing. That's interesting. We really did go left field in this chapter.
It isn't left field to me anymore, and I'm not afraid to talk about this stuff because of the interconnections between all of these facets of life that we just got to look at it and go, like when you pull.
I really didn't expect you to bring up the Bible.
Well,
but what an interesting correlation, because if you do look at that section, I have some recollection of it too. It's like instructions on how to fix wounds and things, isn't it?
Yeah, it's the whole process. Like, this is how you reinvigorate yourself.
Yeah.
And they're talking about the Dead Sea and like the sea ointment. And I'm going, yeah, I know what you're on about. I can see what you're saying. And this is the whole process where we as man think we are smarter than creation. And we need to think again. This whole process and design, and it doesn't matter who you believe in or whatever else, the science, all of it points that it is a far, far smarter creation than what we can ever even imagine. Like, it's just can't even comprehend the extent of how brilliant this is. And yet we want to edit genes and take control and poison things. And gang, do you even understand one little inkling what that will do to you personally, the one that's pushing this process, or to the whole of community? Because it actually brings about a downward spiral. And
another version of the race to the bottom.
It goes hand in hand.
Yeah.
Because people don't look at what nature does, how it can work for you, how that brings yourself, your farm, health. And when you get that health, it brings you profit. And it's funny, I look at the word profit in two ways. It's prophetic, and you have profit.
That's cool. Yeah. Cool way to end chapter 14. We're over halfway through the book now.
Awesome.
I'll see you in chapter 15.
Cool.
Follow along with your own hard copy of the book from efa.nz or listen to the audiobook on Spotify and Audible.